Good afternoon, everyone. My name is Jim Dooley. I'm working the business development group at Viking. I'm based out of Philadelphia, and I'd like to thank you all for joining us today. Brendan Kerrigan will be demonstrating the desktop component of the vCalc program today. Yesterday, he demonstrated the program in a Revit model. So I'm going to let Brendan take it from here. And again, thank you for joining us today. All right, Bren.
Great. Thank you, everyone, for attending today. So as Jimmy mentioned, yesterday we went through how to run calculations based off of a Revit model. Today we'll be focused purely on running them as kind of a standalone desktop application. So outside of a Revit model. So if you did attend yesterday's, there'll be a little bit of overlap on some of the content because it's all kind of ultimately the same program under the hood, but it's probably good as a refresher anyways. So up on the screen here, I've got the main Viking website. So similar to yesterday, I'd just like to point out that under the training drop down here, there is a customer learning portal link. And if you were to navigate to that customer learning portal link and register for an account, we do have some content in there on the vCalc program. So that'll teach you how to do things like manage your internal diameters, equivalent lengths, how to operate the program. It has some explanatory materials on some of the different options, so that's pretty helpful. And then as far as the actual program goes, if you were to go to the digital dropdown, we've got access to some of our web-based utilities. So some of those are kind of product filtering and configuration, such as our sprinkler selector and valve and system configurator. Some of them are estimation based, and these are all websites that'll help you with some special hazards estimates. And right in the middle here, we have our Viking Tools for Revit link, and that'll bring you to our vDesign page. So the desktop version of the program, it's all bundled with the same installer as the Revit version. So if you're to go hit the sign up and download link here, as it says, formerly Viking Tools for Revit, it's all in one, the Revit stuff and the desktop, all one installer. So if you're purely a desktop user, same installer, same sign-up workflow, etc. If you don't happen to have access to the program yet, you can always navigate to the vCalc button up at the top, and there's a Request Access Now link. And if you're to click that, you can just go fill out a little form here that you can just tell us who you are, who your Viking sales contact is, and we'll get your access sorted. So with that said, I'll take us into the desktop version of the program. So once you do install the program, you should end up with a shortcut on your desktop for the vCalc program, and it should be in your start menu as well under Viking. And I've got it opened up here. So once you do launch it, you'll see it open up as its own program. And this is kind of our little splash screen, our welcome page here. So on the left-hand side, you can see this is how you can get into creating a new project, open an existing one. Some of your recent projects will be listed here as well. So if you were to just click on them here, it will open them right up. In the middle, we've got some news from Viking. And then on the right-hand side, we do have a contact us link. So if you ever have any questions, you can always hit that contact us button, and it just brings you to a form that you can submit, goes to our shared inbox, and we can get back to you depending on whatever your question is. So for that, I'll start a new project, which you can just do through the Create a New Project button, and I'll maximize the window here so we can all see it pretty nicely. So once you get into a project, the different sets of information about the calculation are just broken up into a few different tabs along the top here. So the very first tab you're going to land on is your project tab, and it's on this page that you can provide a little bit of information about what this calculation is for or about. And then down below that, we have some configuration options. So this is where you can choose if you're going to be performing a demand or a supply side calc, if you want to use Hazen or Darcy for your friction loss. And then we do have some other more advanced toggles in here. They're somewhat self-explanatory, but we do cover them in the customer learning portal courses as well. So you might want to check that out. As far as entering information into the program, we've got it broken up into, again, tabs along the top. So the pipe sections tab, this is where all of your pipes and hydraulic sections get entered. The simple sections tab, once you've got your calculations running, this is going to show you your simplified sections, somewhat akin to your NFPA 13 pathing. Your supply screen here, This is where you can tell us which node in your pipe sections your water supply is going to be at, as well as what the characteristics of said water supply are going to be, as well as if you need to account for any outside hose allowance. The Design Areas tab is where we can define flowing sprinklers that are nodes on the pipe sections. And then these last couple tabs here, Fixed Flow PRV, this is where you can define a fixed flow for something like a standpipe calc or a pressure reducing valve. The nodes is going to be a summary of all the nodes in the project, and then the bulk edit is just a bulk way of making some changes to your piping network. So when you're operating in the desktop mode, you do need to fill in, obviously, what the hydraulic system you're trying to calculate is. So if I navigate over to the Pipe Sections tab, and I click the Insert a Pipe Section button, you can see it's going to provide me with my first row here in the table, which has all the typical information you might have found on a hydraulic section. So working kind of left and right, you've got your end and your start. So this is where you can provide the noding. This is how you connect pipes up to each other. So these can be any alphanumeric names. So if I wanted my end to be S1 and my start to be A1, I can do that. Next, you can select the pipe schedule for this row. So when you click on that, you're going to get a list of the available pipe schedules. So these are all managed in our component database, which I'll touch on a little bit later here. But essentially, you can pick which schedule of piping you'd like to use. So perhaps schedule 40. And then this is going to make specific diameters that have known internal diameters defined available for selection in the diameter column. After that, you can provide a length of pipe. So here, if this was going to be a typical arm over scenario, perhaps this is a 4-foot section of pipe. The direction field, this ties into our 3D viewer. And if I click on that here, you can see you've got options of plus or minus X, Y, and Z. So when you're working in the desktop environment, if you want to use the 3D viewer, you can leverage these direction fields here. And I'll kind of break into that a little bit after I just show you the purely tabular based input here. But if you just want to work in the table, you can ignore this direction field. After that, you've got your elevations. So the end elevation corresponds with the ending node, and the start elevation corresponds with our starting node over here. And then the final column that we can input information into is our components. So this is where things like our equivalent lengths, our loss curves, our fire pump, etc., get accounted for. So when you click into that, you're going to get a list of your recently used components. And if you see this little heart here, if you click on that, you can kind of favorite a component. So if you're always using the same items, you can favorite it, and it'll always show up in this list here. So if this was a typical arm over type situation where maybe I'm sprigging up, over and down, perhaps I've got a couple elbows and a T on this section. And then when I leave that field, you can see it's gone ahead. It's filled in our equivalent lengths for us, and that's leading to our total section length. Now, when you're inputting information just by hand into the table, you've got a couple different options to kind of continue inputting data. So if I were to click this Insert Empty Section button up at the top, you can see that's just going to put a row in here that's all blank as it was when I first started inputting information. And you could obviously continue filling this in as I did the very first row. We have two other options, which are these two green plus buttons here on the leftmost side, and then this one green plus and kind of the blank box. So this middle button, which says duplicate row when you hover over it, if you were to click on that, you'll see that it's going to carry over all the same information from that original row that I clicked it on. So it's got all the same pipe schedules, elevations, components. So if I had a bunch of typical sections here, all I would have to do is come in, click that duplicate button, and continue filling in the typical information here. The third option is the leftmost, which says copy row. And if you were to click that, you can see that it carries over quite a bit of the same information, but it's starting to try to automatically node up some of the pathing for us. So it's going to take the start node of the row you click that on, put it as our end, and then it's just going to pick our next available default node there. So a couple different options to try to, reduce a little bit of duplication of input there. So I'm going to clean up a couple of these rows here, and I'm just going to sketch out maybe 5 typical arm overs here. So I'll have S4, S5 leading to A4 and A5, and maybe I've got my kind of 5 typical sprinklers here on a branch line. Now that I have this defined, I'm going to need to start connecting up my start nodes here. So this is probably running along a branch line. So if I were to click that leftmost copy row button, you'll see it carry over the A1. I can fill in that this is going to go to my A2 node. I can set a different size pipe. Maybe this is 1.5 inches with 10-foot spacing. It's going to have a 20-foot elevation, so it's not going between two different elevations. And I can get rid of all my fittings there. And then I can just continue using that copy row button to connect up the rest of my A nodes here. So I could go all the way out to A5, hit copy row one last time, and now maybe I have a slightly longer section, something like 40 feet. That's going to go connect up to a riser nipple or something. So at this point, you can continue working your way back out the system. So maybe we're going to go one extra node here. We're going to go from 20 feet to 19 feet. We'll say it's still an 1.5 inch riser nipple, and it's 1 foot long. And then we can go from there, work our way back the mains. So maybe it's a 3-inch main. We'll just say it's 80 feet long. We're going to ignore inputting the other branch lines here just for brevity. And then from there, we can work our way down the riser. So maybe this will be our top of riser node down to our bottom of riser, which we'll call BOR. We'll say that's going to be a 4-inch section. And maybe that goes, we'll say 16 feet, ending at a 3-foot elevation. And on that section, maybe we're going to want to go in, add a butterfly valve, an alarm check valve. And then from here, we can continue on. So if I click that plus button again, it's going to carry over all the same information. So if I wanted to transition my underground, maybe I'll clear out my fittings here. We'll go from BOR to our underground. We'll say that this is now going to be some cement lined ductile iron, class 350 pipe. And maybe it's 6 inches in diameter. And maybe it's 6 feet long, going from 3 feet to a -3 feet. And then we'll just finish this out with a kind of long section of pipe here going out to what we'll call our supply. And we'll just say that's 50 feet or 60 feet. And we'll add a bunch of elbows on here. Maybe it's got a bunch of twists and turns. And this is just kind of walking you through a basic example of how you might go about inputting some typical information into the piping network here. So down at the bottom, you're going to see a blue status message. So mine says source static pressure must be greater than 0. So as you're going through and making changes in your pipe table and elsewhere in the program, you should see the status message updating, just telling you what you're missing in terms of actually getting to a calculation. So what this is telling us is, hey, you've got to go define a water supply if you want us to run calculations. And we can do that by navigating over to the supply tab. So on this tab, we really only have to provide a little bit of information. The first thing we need to supply is what node we want our water supply to be at. So back on my pipe sections tab, I had a node that I called supply in all caps, and that's where I want my water supply to be. Next, we can provide our static pressure, and you can see our status message says, hey, now you need a residual pressure. So now we can provide our residual pressure and our residual flow. And now it's telling us we've got to go define a design area if we want to run calcs. So to actually designate the sprinklers and their flow characteristics, we would then navigate over to the design areas tab, at which point we can add ourselves a design area. You can give it any alphanumeric name you want. I'm just going to call mine DA1 and click OK. And I'm going to go add a sprinkler here, at which point we can call any node that existed in our pipe sections a sprinkler here. So regardless of the name, we just fill in this box here what node we want to be a sprinkler, the K factor of that node, and then we can provide a density, area, and a minimum pressure. So if I was doing an ESFR calc, I might only fill in my minimum pressure here. You can see it's going to come up with the minimum flow based on the pressure and K factor. And you can see that now we actually do have some results. So you can see at the very bottom, calculation finished successfully, took 14 iterations and basically 0 seconds. So again, as you're going through and making changes, this kind of runs the calcs for you. It's always updating. If you don't like that behavior, back on the project tab, there is an enable calculations button that you could toggle off. But usually it's not too intrusive and it's pretty quick to get you results. So now maybe we wanted to fill in a density and area. So we could say, hey, we want 0.2 over a 100 square foot area. We'll see the minimum flow is going to update because the density times area is now driving our flow requirements. And then if we wanted to fill in our other 5 sprinklers, we can use this copy row button on the left, and it's going to bring over all the same information from that original row. And all we have to do is start filling in the nodes that we wanted to treat as sprinklers. So we just fill in the rest of the table here with S1, 2, 3, 4, 5. You can see we have some results for those, and it's pretty straightforward. Now, within a calculation, you are allowed to have multiple design areas. So you can see up the top, there's a drop down that says DA1. And right to the right of that, there's a little plus button. So if we want to add another design area, we can use this, or the button next to it to duplicate the existing design area. So if you wanted to compare and contrast a couple things, and they had identical piping networks, we could duplicate our current design area. Maybe we want to try a different K factor. So we could call this DA1 underscore K8 and click OK. And now we'll see we have all the same information, but we could come modify this one's K factor to be K8. It's going to ask, hey, did you want to change all those rows? If I click yes here, it's going to update every single row to be identical to K8. If I click no, it's going to allow me to mix and match K factors. So if I was in a residential scenario or doing something non-standard, you can have different values in all these different cells here if you'd like to. So I'll click the yes button. It's going to update all the K factors in the current design area. It's going to have our minimum flow updated because the K8 at 7 psi is going to require a little bit more than our 0.2 at 100. And now we're going to have 2 different result sets that we can access throughout the program by leveraging these dropdowns anywhere that you see them. Once you do have some results, if I were to navigate back to our supply tab, you can see that we have a results section at the bottom now. So over on the left-hand side, we have our kind of numerical results, as well as our design area dropdown. And then on the right-hand side, we have our graphical representation of the results as well. And again, to switch back and forth, I can just enter in the dropdown here, switch over to DA1. They're pretty close because there's not a lot going on with only 5 sprinklers flowing here. So that's hopefully pretty understandable how you can access that different information. Once you do have results, the Simple Sections tab is also going to be available. So within this tab here, this is going to be pretty close to what your NFPA pathing would look like. Typically in a hand calc, you tend to kind of self-simplify your piping sections. So it's actually probably going to be pretty close to your original pipe sections. But if you utilize something like our pipe generator, as I'll show later, this can really condense down what you're looking at from a results perspective. So this has been just a very simple hand calc where we purely entered the information into the table here. What I'm going to do is I'm going to start a new project for us, and I'm going to show you how you can utilize our 3D viewer to perhaps do a slightly more interactive data input. And it's usually pretty quick and a bit easier to follow for people rather than just purely working in a table. So very similar to our first example, we just hit the insert pipe section. So all I did there was I started a brand new project up at the top left. It's going to look exactly like it did back when I first entered into the program. So when you're starting out to do a design in the 3D viewer, I typically find it easier to work from my water supply out. So you'll note that here currently our ending column is on the left, our starting column is on the right. If I were to click the plus sign or copy row, you can see it's going to move our start over to our end, and it's going to give us a new node. So this is pretty typical if you're working your way back from the most remote sprinkler head. You kind of start at the most remote head on the branch line and kind of work your way back, as I did in the original example. If you're working with our viewer, I personally, as I mentioned, find it a little bit easier to work from the water supply out. So if I were to go back to my project tab here, right in the middle, there's a sprinkler to source toggle. And if you turn this off, it's not going to have any impact on your actual calculations or anything about the actual hydraulics. But what this does, it kind of swaps around your columns here. So, and some of the automatic naming we do, and it just makes it a little bit easier to work from your water supply out. So in this situation, I'll just get rid of the second row here. I'm going to set my start to a node called SRC. So I called my supply last time. This time I'm just going to call it SRC. I'm going to come into my pipe schedule, pick some cement line ductile iron. I'm going to pick a 6-inch diameter for it like I did last time. Set it to 25 feet long, and I'll just set the elevation to -3 feet. Next, I'll just add another node, and this time I'm going to go and change the direction. So I'll just say this one's going to go in the plus Y direction. I'll set a slightly different pipe length. Maybe this one's going to be 20 feet long. And now what I'm going to do is I'm going to open up into our 3D viewer, which is this little cube icon up at the top. And that's going to open up our viewer. So if you do have multiple monitors, you could obviously drag this off to a separate monitor if you'd like. But for this demo, I'm just going to maximize it on this screen here. And you can see that what we're looking at is kind of a simple representation, just corresponding to an XYZ axis of what our piping network looks like. Up at the top here, there's a couple different tabs. So these correspond to the selected elements. So when you're in this view, you can actually select pipes as well as nodes. The graphics tab has a lot of different yes and no options. A lot of these are results based. So once we do have some calculations results for this, we can turn things like the flows and velocities on and off. For now, I can turn the lengths and diameters on. So you can see I had that 6-inch, 25-foot long pipe coming out of my supply that I called source. And then I've got that 20-foot long pipe here. The final tab is results. So again, we don't have any calculation results right now. You can see that we hadn't input a water supply yet. But once you do have results, this will be your graphical results and your kind of an easy way to go and check where you're at in terms of your system capabilities versus what the water supply has available. So within this viewer, as I mentioned, the very first tab corresponds to selected elements. So over here we have our selected pipe, and it currently says no selection. So if you were to click on a pipe in the viewer, you can see it's going to start filling in all these different things here with the information corresponding to that pipe. And you can actually edit them in these dialogues here. So if I wanted to shrink that pipe down to 5 feet, once I leave that field, you can see it's going to update my view here. So this is where I was mentioning if you wanted to have kind of an interactive sketch out of your system, this is a pretty easy way to do it. If you click on a node, you're going to have your selected node information filled in over here. And then all these dialogues here allow you to specify the next type of pipe that you'd like to create. So here, similar to our first example, maybe we want to sprig up about 5 or 6 feet. We want it to be some more cement lined ductile iron, and we're going to want it to be in the plus Z direction, so that's up. And again, there's a little tripod in the bottom left that'll show you what the different directions are. So as you kind of spin the viewer around, you can see that change with you. So you've always got a bit of a reference about what's up, down, left, and right. To create that pipe, you just hit the create button, and you can see it's going to kind of interactively show us here. So now it becomes pretty straightforward to sketch out our system. We'll do the same transition to schedule 40. We're currently at a 3-foot elevation we can see here. So maybe we want to go up to 20 feet. We'll go with a 17-foot long pipe, and we'll make this 4 inches. Click create. And then now maybe we want to start sketching out our main. So we'll transition to a plus X or plus Y direction, perhaps. And again, since this is a kind of simplified representation, maybe this is going to be a 60-foot run. We'll make it 3 inches in diameter. Click create. And then now maybe we know we want to calculate 3 branch lines, and it's going to be a 10-foot spacing between each branch line. So we can set our dimension to 10 feet. And you'll notice that when I hit create, it actually follows the node. So when we create the new node, it jumps to the next one, assuming our follow nodes option is yes. So that allows us to pretty easily keep clicking create and create a bunch of typical pipe sections. Now I'm going to make a little 1-foot section at the end here, because you'll see that in the background, this isn't currently filling in any fittings for us. So when I go and run our fitting generator, having this extra little section here is just going to denote that our riser nipple should get assigned a T rather than being an elbow down here. So now we've got our main kind of sketched out. Maybe we'll transition to some 2-inch pipe. 1 foot in the plus Z. We'll make some typical riser nipples here, just going up 1 foot. So we just click each node and click create. And then now we can start working out our branch lines here. And I'm going to turn a little bit of the labels off just to make it a little bit simpler. So now we're going to want to go in the plus X direction according to our tripod. So again, you don't have to model out every pipe. As long as it's the same diameter, you could just make one long run here. So maybe we'll go 45 feet out in the plus X direction, and we'll create a typical section on each of these riser nipple nodes here. And then from here, we can start sketching out our sprinklers. So we'll just say it's all 2-inch branch lines. There's going to be a 10-foot spacing between heads. And again, we can rename the nodes. So I'll call this very first one here S1. And when I click the create button, you'll see it's able to carry over some of that naming. So if I had 5 heads on this branch line, I can pretty quickly array out that typical spacing. I'll do the same thing on the next branch line, starting at S6. Click create a couple different times just to get it all to match up. And then finally, I'll do that on the bottom section here. So that's going to be S11. And we'll just say there's only 2 heads in this specific area. So at this point, we've got our very simple little pipe sections kind of sketched out here. The next step is to create our design area. So obviously at this point, we could go back into our full user interface and we could go fill that table in. Or an alternative we could do is in this viewer, we can use the create design area button up at the top. And when I click on that, it's going to put me into a mode where my tab now changes to design area up at the top. I can provide us with a name, and then I can choose if I want to do a density and a pressure or pressure only. So if this was a CMSA or ESFR design, I might use the pressure only option here, and that just means you don't have to fill in the coverage area and density. So here I know it's actually about 1,200 square foot coverage, but again, you're going to provide that information to us, the density over that entire coverage, the K factor, and the minimum pressure. And then to actually pick the nodes, you drag a window around which node you'd like to flow. You can see the selected node names kind of filled in this comma-separated list up top. And then once you're satisfied, you can just click the Create button, and you'll see that these are now changed to a red sphere with a cone, signifying they're a sprinkler. But you can see that currently they're at 0 PSI and 0 GPM. So again, our little status message is here telling us what's going on. So it's source static pressure must be greater than 0. So what we've got to do is go define our water supply. So I'll close down the 3D viewer, and now you can see that the piping network has been kind of filling in the background here. But as I mentioned earlier, it doesn't currently have any components filled in for us. So it doesn't have any of our elbows or any of our T's. So that's something we're going to want to rectify. Obviously, we can go through and manually assign these things, but up at the very top, 2 to the right of our 3D viewer icon, this kind of grooved elbow, if you click on that, this is our fitting generator. And what this does, it looks at your changes in directions based off of what you've kind of 3D modeled, and it's going to automatically add elbows, T's, and crosses based off of these connections. So when I hit the create button here, it's going to go through and it's going to add all my elbows, T's, and crosses based off of those direction changes. And for some reason, it's not working in the demo, which is always great. But anyways, typically that'll go through and add all those fittings for you. But again, you can come back and add these manually as well. And it's most likely because I don't have a water supply defined. So if I add my source node here, I fill in my static pressure, residual pressure, and flow, and go back to my pipe sections, run our fitting generator. And the purpose of that is that it works out from your water supply. That's how it gathers your direction changes. And you can see that here it's gone ahead and actually worked that time, and it's filled in our elbows and our T's on our riser nipples. These are little 1-foot sprigs right here as well. Now you're not constrained to this, so maybe you knew that maybe on this longer main run here that was 60 feet, maybe you knew you had to swing around a couple things. So you can obviously come in here, add a few extra elbows, and then you can see that equivalent length's going to pop in as well. So that's how you can go in and pretty quickly input all that information there, fill in these design areas based off of the 3D viewer there, and then continue on from that. So another option, if you want to generate a starting point for yourself, if I start a new project here, is to utilize our pipe and system generator, which is this middle button up top between our fitting generator and our 3D viewer. So if I start a new project, which I just did, and navigate over to our pipe sections tab, you can see it's currently empty. And if I click this pipe and system generator button, this is going to open up what we call, again, our pipe and system generator, just pipe generator. And what this allows you to do is fill in some typical information. And what we'll do is go ahead and generate a starting point for you based off of what you've asked us to do in this dialog here. So it'll be pretty straightforward for us to fill in a system very similar to what I just showed you guys. So the very first option for you is what type of layout you would like to start with. So we offer the ability to generate a tree, grid, or loop type system. Usually for this specific utility, we see quite a bit of interest in it from an estimating perspective. It's pretty quick to generate a relatively large size system, and it's good to match it up against your water supply, perhaps size a pump, and so forth. So by default, we're just going to show you the tree type layout. If I were to click on the gridded system, you can see it's going to kind of change what it's showing us here in the preview, and this is what a gridded system might look like. If I go to the loop type system, you can see that based on all the current options, this is what that loop would look like as well. So I'll walk us through a tree type system here. So if I switch back to a tree, you can see that we've got a few different inputs here along the top. So the very first section for us is the underground, which is going to comprise this SRC to UG, and then up to our base of riser here. So we can fill in a length for that section. Maybe it's something like 80 feet long. We can define the elevation for it, the pipe schedule we'd like to use, the pipe diameter as well. Next, we have our riser information. So we have the start elevation of the riser. So this is where our underground pipe is going to kind of come up. If you don't want to use that, you can just match it up to the underground at -3. Or if you want to set it up a little bit higher on your system, you can obviously modify the start elevation here and kind of observe the impact in the preview that we're looking at. And it's going to be some Schedule 40 pipe, and we'll say it's going to be 4-inch diameter. Next, as we move over into the main and branch line sections, the elevations start playing a bit of a role as well. So you can see that our main branch line here, or our main elevation rather, is currently at 19 feet, and our branch line elevation is at 20 feet. And you can see in our little preview here that we also have a little riser nipple present. So that's based off of the elevation difference that you're inputting here. So if these were both matched up at a 20-foot elevation, you could see that there wouldn't actually be a riser nipple there. You would just end up with a cross type fitting when we end up generating this out. It's very similar with the sprinkler elevation input. So if your sprinkler is right on the branch line, there's not going to be any sprigs or drops, but if you put that elevation above or below, you're going to end up with a pipe segment leading down to that. And all these diameters are customizable, so you can customize the riser nipple and the sprig and drop diameters independently as well. So for simplicity, we'll put our sprinklers back at 20 feet, we'll put our main back at 19 feet, and we'll continue working through the inputs here. The other option in the middle is the main location. So this is available on the tree and the gridded systems. So currently we have a center feed system right here where the sprinklers are kind of evenly distributed on either side of it. If we wanted to go to a side feed system, we just change to side. And you can see that that would move all of our sprinklers to one side of the main over here. And there is even some customization here under the fine tuning input, where we could define a number of sprinklers on outriggers. So if I set that to 2, it's telling it to put 2 heads on one side of that main and then the rest on the other. As far as the overall spacing between heads and between branch lines and the overall quantities, that's finally in our spacing section of the dialog here. It's pretty self-explanatory. Branch spacing controls the spacing between our branch lines, quantity of branch lines. So if I up that to 15, you can see that our system will kind of array out a bit here. Sprinkler spacing is our spacing along the branch lines themselves. And then finally, the quantity of sprinklers per branch line. So if I up that to 15, we can see that array out as well. Once you're satisfied with the overall layout of the system, there is a sloping tab. So if you wanted to try to apply some slope, you can slope the main or each side of the branch line. These options might be a little bit different depending on what type of layout you're in. We'll leave ours kind of flat for now. The sizing tab, so back on the layout screen, I had chosen a nominal 2-inch diameter for all of my branch line. So every single pipe here is going to be 2 inches. And that is what we call our uniform sizing. An alternative we offer to that is what we call telescoping. It's kind of like your NFPA 13 pipe schedule method. So if I were to choose the telescope size, that allows me to look at this table here where I can define a certain quantity of sprinklers per diameter. So if I wanted only one head on 1-inch pipe, I can just fill this table in, 2 heads on 1.25 inches, 5 on 1.5 inches. And as we work our way back towards the main, these pipes are going to be sizing up depending on the quantity of sprinklers that are downstream of them. Our final input here is our design area. So this is kind of our initial guesstimate of what your remote area might be for that specific system. So you can see it's got some default values in here. So default coverage area of 2,000 square feet. And you can see that some of our nodes are red and labeled here. So this is the same as what we're looking at earlier in the 3D viewer. These are kind of our theoretical heads in that remote area. And if we want to up this area or downsize it, so change it to 3,000 square feet, when I leave that field, you're going to see a different set of heads get selected here based off of the typical NFPA quantity of heads per branch line. So that's what this design factor over on the right is. If you need to use a 1.4 design factor for determining the quantity of heads per branch line, you can change that over here. So we'll just proceed with our 2,000 square foot coverage with a 0.2 density. We'll leave our K56 heads with a minimum pressure of 7. And now if I kind of minimize our preview here, you can see that still in the background, there's not currently any pipe sections. So when I hit the Create Pipe Table button and this green bar fills up, you'll see that it's going to go ahead and I've filled in our table for us for all of our pipe sections. It's going to have assigned all of our fittings. So you can see here that it's gone ahead and assigned 259 different pipe sections in here. It's assigned our fittings. So we've got things like the T's on our riser nipples and up at the branch lines. And if I scroll all the way up to the top here, you'll see that it has an initial riser for us with a butterfly valve, an alarm check valve, and an elbow. So what we've done here is we've generated a starting point for you, and then obviously you can customize this to suit whatever you need. So if you wanted to add a pump or add additional sections, etc., that's all available here as well. So now that we have a slightly more complicated system, and it's gone ahead and created our initial design area for us as well. So you can see we've got some results in this table, but you might notice that a lot of these are zero flow. So we created every pipe that you saw in that preview. A lot of those branch lines were not flowing, but those are still here and represented. You could use those for alternative design areas or other situations that may arise. This is where I can point out what the purpose of the Simple Sections tab is, because again, we've got 200 something different pipe sections here. It's a little bit convoluted. However, if I navigate over the simplified sections, you can see that we can boil that down to only about 34 different pipe sections for us. So anywhere that you see these tables, they're actually sortable as well. So I can see down in my status message that I have a negative safety margin of about 25.8 PSI. So if you're kind of curious where you're losing a lot of friction, you can actually use these column headers to sort by things like friction loss descending. So I can see that my 3-inch mains here may be causing a bit of issues based off of the information that I put in, or I could sort by velocity, for example, and try to use that to determine what's going on. If I go back into my 3D viewer, now that we're in a situation that does have some results, if I kind of zoom in towards our remote area here, you can see that we have our pressures at each of our sprinkler nodes, as well as our outflows. So if I were to navigate over to our graphics tab, we've got a lot of different options in here. You can change the size of the labels, the offsets, but I'm going to turn a little bit of that information off just to simplify it a little bit. I'm going to turn some of my pipe labels back on, and I'll determine, or I'll take out the length, take out the flow, but I'm going to keep my velocity and my diameters here. So another method that might typically be helpful for finding potentially problematic areas in the calc is looking at high velocity sections. You know, it's a lot of water flowing through a small pipe relative to that flow. So as I kind of tab around here, I can spot some higher numbers like 17 feet per second. I know back over on my main, it's about 20 feet per second. So obviously you could sort that table I just showed you. But another method we have here is under the results in the graphics tab, where you can change your pipe color method to work off of flow or velocity as opposed to our default method. So if I change that over to velocity, I can set a threshold here. So I'll say, hey, maybe 16 feet per second. And what this allows me to do is actually color in the different pipes that are exceeding that threshold. So it's a somewhat interactive way of trying to spot problematic areas in your calculation file. So since it looks like maybe these 1.5" sections are causing maybe a bit of a problem for me, obviously I could click on these one by one and size them up back over here in my selected element tab. But this is also a good time to show that we have a multi-edit button up at the top right next to our create a design area. So if I go into that mode, it's going to allow me to actually drag a little window to select multiple pipes. So I'll grab all 4 of these pipes right here. And then now I have a few different options of what to change. So I could say, hey, let's size these all up to 2 inches. Click the set button, and then it's going to make that change, and we can see that impact our results right away. So that drops it down to about 10 feet per second. And I can see I'm still working at a negative 21 PSI safety margin. So I didn't quite get us to where we might need to be, but I know that these main sections over here are also causing a bit of an issue for me. So I could or I could leverage the same thing. I could use our multi-edit to try to grab all these main sections and change them. But I'm going to minimize my 3D viewer here and take you to the last tab in the program, which is our bulk edit. So what this does is it groups together all your typical sections in the piping network. So here, if I kind of look through, I can see some of my 3-inch sections. So on our main, we had a little 5-foot long section coming off the top of the riser. We had 14 other branch lines at our typical 10-foot spacing. So what this allows you to do is make bulk changes pretty easily. So we can size up all 14 of those in one go, and we can size that one off the end of the top of the riser as well. And if I bring my 3D viewer back up, you can see these have all been resized to 4 inches. We've got a slightly better velocity here, and I can see my safety margins actually up to positive 2 PSI. So if I go look at my results, I can see I'm just a little bit under the curve here. So we've actually made quite a bit of progress. So once you're kind of satisfied with your system and you want to actually print it out or kind of create your submittal, something else you can do in our 3D viewer here is take some screenshots. So here, if I kind of orient my view over my remote area, maybe I want it to be at kind of a slight angle here, I can go up to the top right, hit the screenshot button, and I can assign a name. So maybe this will be my remote area picture. And then if I wanted to take another picture, maybe I want to go to somewhere else in the view, kind of looking over at my riser and my underground, and we'll just call this my riser. So I'll hit the screenshot again, call this my riser, click OK. So now I've taken a couple screenshots. I've got some results. I've got, just a tiny little safety margin here. If I want to print this out, I can go up to the top to the little printer icon and click Create a Submittal. And that's going to pop up our little dialog here that has the different options for what we want to print out. So up at the top, we're broken out into a few different tabs. So this is kind of the typical cover sheet information you might find on your printout. On the very first tab, we've got our print options. So this is where you can pick which information you'd like to include or not include. So our first column here, this corresponds with each of these tabs along the top. So if I'm not going to fill in the notes, the contact, or the water supply info, I can just uncheck those items. Next, we've got some different results that we want to include. So the flow test summary, supply analysis, the full pipe table, and simplified pipe table. And I'll also include our EQL details as well. But these are all typically results-based information. And then as we look through the report, you'll kind of see what those correspond to. And then finally, since I did have a couple of different pictures here, I can click the Include and Submittal button on each of these pictures, and I can click the Print button. But first, I'm going to go over to my Design tab, fill in a little bit of information. So maybe this was an ordinary hazard situation. It was a 2,000 square foot, or rather a 0.2 density over 2,000 square feet. And I did 20 different sprinklers, so it's 100 square foot per head. So you can kind of choose what you want to fill in here, leave blank what you don't want, and then click the Print button at the bottom, at which point it's going to open up in your default browser as an HTML file. So from here, you can obviously just Control-P or right-click Print, and you can save this as a PDF. So this is how you can get kind of your PDF version of the submittal. And if I scroll down a little bit here, you can see it's a reasonably well paginated set of information, but I'll walk us through in the full kind of larger view what's included here. So here up at the very top, we have our version of the calculation. So this is the version of the software that the calculation was performed in. Then we have our cover sheet information. So this is all that information that you did or didn't fill out on those dialogues. And then some of it does come along for free. So for instance, it will call out things like your total system volume here. If you had some dry pipes defined, we would break that out separately. And then we've got things like the supply pressures, all the calculation options, etc. Down below that, we have our graphical results. So this is going to be a reproduction of that graph we saw back on our supply tab and in the results tab on the 3D viewer, as well as our numerical results. So on the left-hand side of that supply tab, we had just a table of information. So kind of the numerical points corresponding to each of the points of the graph up top here. So these are all those numbers in just textual form. Down below that, we have our design area analysis. So this is our summary of all the important nodes in the project. So you can see we've got our sprinklers, we've got our branch line nodes. So this is kind of our significant nodes, what their elevation was, their K factor. If they're a standpipe calc, we'll have a hose allowance assigned to that node, a PRV, if they were defined as a PRV, and then we have our pressure at each node and the flow. So this is the actual outflow of each of those sprinkler heads. Down below that, we have our kind of pathing. So this is our NFPA 13 style pathing. So our first path here, path 0, that's going to start at our most remote sprinkler head, which is S1 in this scenario. And it's just going to work its way out through all of the connected nodes, connected piping, all the way back out through our riser, through all the piping back to the water supply. Down below that, we're going to end up with how many other paths it takes to represent all the other flowing nodes. So here you can see that our second branch line leads back to RN2, which is a point back on our original pathing up here. And then we'll end up with a third path because there's only, well, I guess there's 4 branch lines. So we'll end up with a third and a fourth path here. So just representing all the different flowing nodes in the project. Down below that, we have our pictures. So we took a little picture of our remote area. So you can include some kind of simple isometrics with some context. So you can have kind of whatever graphical things turned on and off. So I had the diameters and velocities turned on when I took the picture. So you can see that that kind of flows through into that on the submittal printout here. And then I have my riser picture as well here. So up to you what you want to take screenshots of and kind of what information is included there. Down below that, we have our simplified pipe table. So this is all the same information back in our simple sections tab. So it's kind of our flows, our friction losses, starting and ending pressures, velocities. So this is kind of the most condensed view of all the data from the calculation. Down below that, I opted to include our EQL basis. So here you can see that we used a butterfly valve, a J1 alarm check valve. We had some elbows and T's. And this table here is telling you what the basis for all the equivalent lengths was. So you can kind of match this up back with the table above to backfill, why a certain equivalent length was used, depending on which components were present on each pipe section. And then down below that, we have our full pipe table. So this has literally every pipe in the project. So if I kind of scroll a little bit here, you can see there's a lot of information here. This corresponds with that pipe sections tab. So if you recall, there was about 250 or 60 different pipe sections present. And this does have a bit of extra information on it. So it's got the internal diameters, it's got the C factors, the roughness coefficients. So it's really kind of a full data dump of what the inputs and outputs of the calculation were. Probably a bit much for your typical printout, but the option is there if you did want to include it. So that kind of covers most of the usage of the desktop application. What I haven't covered yet is our component manager. So back on the pipe sections tab here, when I was going through the different drop downs, that was giving me different pipe schedules, giving me different components to use like T's and elbows, the different sizes of each pipe schedule. That's all managed in what we call our component manager, which you can access up at the top. It's this little component manager button. And when I open that up, that's going to open up another dialog for you. And what this is kind of our database of hydraulic components. So this is where all those internal diameters and Z factors and everything lives. So that's why I didn't have to fill in things like equivalent lengths for elbows. as I was going through the various inputs there. So within here, we give you kind of a starting point, and what we've got is some high-level categories, kind of classifying the different things that you might find on a typical system. So if I were to go into our backflow preventers here, we've got a few different categories. So if I go into AIMS and click on the first item, the AIMS 2000 SS, you can see that when I click on it, I get a little bit of information on the right. So we've got a details tab, a curve data tab, and then a Revit family/type. So most important for people, especially on the desktop one, is going to be your details, and then your second tab here, which is going to be your hydraulic information. So on the details tab, you can see that the component name is here, but it's kind of grayed out. And you can see there's an owner that says V. So as I mentioned, we kind of give you a starting point here, and all those components come from Viking. So the owner for those is going to be V for Viking. And those are not things that you can actually edit or make changes to. However, you can go ahead and augment this database with your own components. So you can create your own high-level categories, subcategories, and components. So if I click on my BFP here, you can see that I could go click in and edit, and that the owner is you. So it's a user-based component. So this is kind of system-wide. So once you've created a component, you can keep using it over and over in different calc files. It's not just specific to one calc file. And that all lives in one file called our components database. So if you did want to distribute that to other users in your organization, you could always just contact us and we can give you a little bit of information about how you might go about doing that. As far as the components themselves, there's a few different types of components. So the first one I clicked into here is in the backflow preventers section. So this is probably our most complicated type of component, which we call a curve type component. So if I click on our second tab here, it says, hey, this is the curve data tab. And what we have on the left-hand side is a list of nominal diameters. And if I click on the 4-inch here, you can see that this one actually has some information. So it has a bunch of X and Y coordinates corresponding to flows and pressure losses. And that's what's building out our table over here on the right-hand side. So typically with the backflow preventers, if you were to go to the manufacturer's data sheet, they distribute essentially loss curves at each nominal size. And what you can do is through the X and Y coordinates here, you can reproduce the loss curve based off what the manufacturer designated. So here we're seeing the loss curve for the 4-inch. If I were to switch over to the 6-inch, you could see we'd end up with a slightly different loss curve here. If I go to the 8-inch, again, a different set of X and Y coordinates and a different loss curve, different flow values, etc. So that's why this is one of the more complicated types of components, because this is the one that's kind of the most data heavy if you do actually want to add them yourself. Another use of the curve type components is if you want to take a flat loss. So typically you see in some situations that they may say, hey, we want our backflow preventers to just take a flat 8 or 12 psi loss. And you can implement that by just drawing yourself a flat curve here. So if I go to my 4-inch size, you can just add a 2-point curve that's flat at 8 psi. This is one way of doing that. A more typical type of component, if I go over to our fittings category, you can see we provide some default standards like NFPA 13 and FM 3.0. And if I go into NFPA 13 and click on the elbow, you can see that our second tab up top is actually going to be our EQL data tab. And if I click over to that, you can see that it's a lot more simple here. This is just filling in an equivalent length for each of these nominal diameters. So that's going to be your equivalent length of Schedule 40 C120 pipe. You can just fill that in here. And back in the user interface, when I was adding, 9 elbows or multiple elbows to a segment, it's going to go ahead and pick out the right equivalent length for each size. It's going to adjust it if needed. So if it's a different C factor, a different internal diameter, it'll do all that for you, and it'll apply it to that pipe section. We also have the idea of flex pipes in here. So we give you a starting point with some ASC Superflex. This plays a little bit more into the Revit side of the house for things like the safety length and the overall length, but you can assign these to different pipe sections. So you could have little flex pipe sections in there as well. So here you can see the nominal length of the flex pipe and its equivalent length. So we give you kind of a limited starting point here, but you can go ahead and add whatever you might need. As far as the different pipes go, if I maximize all these pipe sections, this is where all those options come from back when I was kind of applying a different pipe schedule. So if I were to click on our Schedule 40 here, you can see it's a lot of the same details, but under the optional section, you can see this is where your C factor and roughness coefficient live, as well as a little dry pipe toggle. So that's why there's a differentiation between things like Schedule 40 and Schedule 40 dry. So if I click on the dry variant, you can see it's our C100 version. So this is how you can take into account the different C factors. And this dry pipe toggle here, if you recall in the report, we do sum up the volume of the dryer pre-action system. That's all based off of this toggle, signifying it's supposed to be treated as a dry pipe. Similar to the equivalent lengths, if I go over to our pipe data tab, you can see that we just have a list of nominal diameters and internal diameters. So you'll notice that a lot of things kind of cut off at the 12-inch section. So we've kind of filled in based off NFPA for a lot of these. Some of them do go a bit bigger depending on which pipe schedule you're in. But again, you can go ahead and augment this with whatever parts you might see that you need. And you can also duplicate our component. So if you wanted to make your own copy of Schedule 40, you could right-click ours, duplicate it. It's going to carry over all the same information that you saw in this dialog here, and then you go modify it to be whatever you'd need. And then our final type of component is pumps. So we do offer the ability to solve through pumps. And for those, you're going to have a pump tab up at the top here. So we give you a couple examples of some kind of stock NFPA 3-point curves. So like 110 or 20% churn, 150% flow at 65% rated pressure. And those are just simple little 3-point curves here. But you can go ahead and add your own specific manufacturer curves. So again, you're just adding a bunch of X and Y coordinates here to build out whatever the manufacturer's documentation indicates is necessary there. So for all these different types of components, we do have courses in that customer learning portal that cover how to go through each and every one of these and kind of add them step by step. So it'll show you how to create this one and so forth. So that kind of covers the bulk of the information regarding the desktop usage of the program. I think the only thing I didn't really get into was our fixed flow PRV tab. It acts very similar to the design areas. So if you just want to add a fixed outflow somewhere, you just add a fixed flow, type in the node name you want it at. So maybe at the top of riser, you want a 250 gallon per minute flow, and you can provide an optional minimum pressure. And this is just a static outflow with that element. So I think that finishes it up. I'll take a look, see if there's any Q&A here. Anyone asking for answers? Let's see, can the 3D model generated from this program be inserted into a Revit file? No, that cannot currently be done. Can I transfer my component manager customized database from one PC to another? Yes, you can do that. Feel free to submit a contact us or email us if you want some more specific kind of detailed instructions. But it's just a .db file that lives in your work folder. So that's hopefully pretty easy. Let's see, chat. Can friction loss per section be shown in the graphic page? I'm assuming you're referring to the 3D viewer. There is no option to show a friction loss on a specific section, but there's a lot of demand for that. We could add it. Again, you can sort by the different sections in the different tables, so that might help you find some high friction loss stuff, but there is no label in the 3D viewer. Where can we find the recorded sections, and will they both be available? Yes, they will be available. They're going to be in the customer learning portal. I think that was answered afterwards. Is there any way to model a horizontal angled pipe? You can. So if you were to supply a differing elevation, so this might turn red, but if I were to change my ending elevation here, my starting elevation, so maybe if I made this 22 feet, you can see that it gets kind of an angle here. So again, you're going to want to check and make sure you're using the right length of pipe. But if you'd had a differing elevation on a plus X or Y or minus X section, it will allow you to kind of sketch that in there. But if you mean at like a 45-degree angle, no, you're a little bit locked into the XYZ coordinates. NFPA 13 no longer has a limit to the fluid velocities for the interior of a sprinkler system, but relies on an individual to know the limitations of Hazen Williams versus Darcy Weisbach. FM Global still identifies a maximum limit of 30 feet per section for interior pipe. Does vCalc identify when the velocities exceed the FM Global values? We do not call them out. There's no specific warning, but if you were to navigate to your pipe sections or simple sections tab, you can sort by velocity descending, and this is one way for you to self-check that. Or alternatively, as I showed earlier in the 3D viewer, you can set your own velocity threshold and set it to color by velocity, and that's another way of checking your piping network. What's it look like when you click Add a PRV? So if you were to click Add a PRV, very similar to the fixed flow, you just define the node that you want it to be at and the maximum pressure you want to observe there. It's probably a little complicated to explain in the 0 minutes we have left in the webinar here. So if you want a more in-depth explanation, we can go into that. I think it's covered in the customer learning portal as well. But basically, if we see a pressure exceeding this maximum pressure at that node, all downstream nodes will see the limited pressure. I know that's a very short explanation, but yeah, you could reach out if you'd like something a little bit more specific about that. But yeah, and in that situation, the starting and ending nodes matter quite a bit. So back on the pipe sections tab, I need to assign a valid node there, so I'll just delete it to get back to some results. So back on our pipe sections tab, if you happen to notice, there's a flow direction. So flow direction of 1 means it's flowing from the start to the end. Flow direction of -1 means it's flowing from the end to the start. So that matters quite a bit in the PRV. It expects downstream flow from start to end. So again, we can talk about that if we really want to in a more detailed explanation. And I think that covers it. I think we're caught up on the questions. And again, we're up on our time here. So I'll hand it back to Jimmy. I think he wants to mention a couple other potential webinar topics that he likes to advertise.
Okay, thanks, Brendan. Yes, today's recording and yesterday's recording will be available in the Customer Learning Portal and on our YouTube page. We have other webinar topics that we can provide to your individual companies if you're interested. 3 of the more popular topics in the fire protection industry today are protection of lithium batteries, lithium-ion battery protection for storage. We also have a webinar that will do a review of upgrading from an AFFF foam system to a synthetic fluorine-free foam system. That's a popular webinar. And another webinar that has garnered a lot of interest is FM Global's revisions to FMDS 8.9. So if any one of those webinars are of interest to you, please reach out to me and we can arrange and schedule a Teams meeting for your group. Again, I'd like to thank everyone for participating in today's webinar, and hope you all enjoy your weekend and have a nice day. Thank you very much.